Suppose w equals f of z is a transformation where z is a complex variable represented by z equals x plus iy and w is another complex variable w equals u plus ib. To represent the transformation graphically, we have to make use of two copies of complex plane. The z plane with the x-axis and y-axis that records the inputs, and the w plane with the axis u and v which stores the output of the transformation f. Suppose that we have two curves C1 and C2 lying in the z plane and they intersect at point P. Suppose their images in the w plane are C1 dash and C2 dash, and these images intersect at point P dash. If we have the angle of intersection of curves C1 and C2 at point P in the z plane is same as the angle of intersection of the images C1 dash and C2 dash at point P dash in the w plane, if both in magnitude and direction these angles are equal, then we say that the transformation w equals f of z is conformal at point P. That is, a transformation which preserves angles both in magnitude and direction between every pair of curves through a point is said to be conformal at that point. We cannot always draw graphs and check whether the given transformation is conformal. So we have a sufficient condition to check whether the given transformation is a conformal mapping. The condition is that if f of z is an analytic function of the complex variable z in a given domain D, and if f dash of z not equals 0 everywhere in the considered domain D, then we say that the given transformation w equals f of z is conformal at all points in the considered domain D. Or if we restrict the definition to a single point, we can have, suppose f is an analytic function and z0 is a point in the considered domain D. If f dash of z not equals 0 at the particular point z equals z0, then we say that the given function f of z, which is analytic, is also conformal at the particular point z0. If for every point z0 in the considered domain it satisfies f dash of z not equals 0, then we can conclude that the given function is conformal everywhere in the considered domain. Suppose in the considered domain D you find certain points z such that f dash of z equals 0 or f dash of z does not exist, then you call such points as critical points. And if other points exist such that f dash of z not equals 0, then we call those points as ordinary points. The points at which w equals f of z is not conformal will be called as critical points, and the points at which the given function w equals f of z is conformal will be called as ordinary points.